integration by parts. This is where we get to learn to deal with a product. So we're going to take the product rule, take the derivative, and then go backwards to find out how to undo what we did. So derivative of a product, derivative of first times second, first derivative of second. Y was f times g, so we're just going to replace y with f times g. So the derivative of f times g is f prime g plus f g prime. Now we're going to integrate both sides of the equation. You're allowed to do that because you've done the integral of both sides. The integral of the derivative of f times g. The integral of the derivative. Those two undo each other, so that just becomes f times g. This integral you can write as the integral of f prime g plus the integral of f g prime. So all we did is take the integral of each term on this side of the equation. So let's look at that again. We took the derivative using the product rule, replaced y with f times g, took the integral of both sides of the equation, said the integral of the derivative of just what we started with, and this one we're taking the integral of each term. We're going to rearrange it a bit. We're going to replace f prime with df and g prime with dg. And then we're going to get f dg by itself. So we replaced f prime with df just to stand for the derivative of f, g prime with dg to stand for the derivative of g, and then got this expression by itself. So we took that one to the other side. So this is really how we're going to integrate products. Now at university, they tend to use u and v instead of f and g. So instead of f, everywhere you see an f, we're replacing it with u. So df becomes du, and all the g's become v's. So df, g becomes v, dg becomes dv. And this is a rule that you memorize. The integral of u dv is uv minus the integral of v du. So how does this work? We have the integral of x e to the x dx. This is the rule we're using. The integral of u dv equals uv minus integral of v du. So one of these is going to be u, and one of these is going to be dv. How do you decide? dv, you absolutely must be able to integrate it. So let's look at both of these. Can you integrate x? Yes. Can you integrate e to the x? Yes. So you still have two choices. If your answer was yes to only one of them, that would be the function that you would replace dv with. So because we have two choices, we're going to look at this one now. U is the function that becomes more simple as you take the derivative. So e to the x derivative is e to the x, that doesn't change. X derivative is 1. That is more simple in that the exponent is getting smaller. So what we're going to do is let u equal x and dv equal everything else, which is e to the x dx. So u is going to replace x. dv is going to replace e to the x dx. And then this expression can now be written in terms of u's and dv's. So if u equals x, what is its derivative? Derivative of u would be 1 dx. If the derivative is e to the x, what was the original? The original function is e to the x. You're accustomed to putting plus c in, but with this, because there's so much taking of integrals, taking derivatives, we'll just put the plus c in at the end. It really doesn't change anything. So what happened again? We had to replace for u and dv. We did that. And then to get from u to du, that's taking a derivative. To get from dv to v, that's integrating. Now you substitute like crazy. All the u's become x. All the v's become e to the x. dv is e to the x dx. And du is dx. So u became x. dv e to the x dx. u x v e to the x minus the integral of v e to the x du, which is dx. So if you've done your substitution correctly, this integral will be the question that you started with. And it says the integral of x e to the x is equal to x e to the x minus the integral of e to the x. And we know this answer. What is the integral of e to the x? It's e to the x plus c. So we've managed to integrate this. And it looks like a little bit of magic because you're thinking, well, I didn't really work that hard. How can this possibly be the answer? So let's verify it and see if it works. If we take x e to the x minus e to the x plus c as our original function, take the derivative, this will be a product rule, derivative of first times second plus first, derivative of second, minus derivative e to the x and derivative of c. These e to the x will eliminate each other, and we'll end up with x e to the x, which is what we were trying to integrate. So this is the antiderivative of x e to the x. So we know this works. Still looks a little bit like magic, but we'll get better at it. Let's try another one. X cos x dx. Our formula for today, integral of u dv equals uv minus v du. We're going to let u equal x again. Why did we make that choice? Can you integrate cos x? Yes. Can you integrate x? Yes. Which one gets more simple as you take the derivative? Cos x, negative sign, so they're about as difficult as each other, whereas the derivative of x becomes 1, which is less complex because the exponent is getting smaller. So if u is x, dv is everything else. Once you find those, to figure out what du is, you take a derivative. Derivative of x is 1 dx. To find out what v is, you integrate. What is the integral of cosine? What has a derivative of cosine? Sine does. And a bit of a warning on this, when you're taking derivatives and integrating in the same question, the trig functions and the plus minus signs get a little bit confusing. So I always take my best guess and then double check to make sure it's right. Derivative of sine, cosine, so we know we're right. We'll keep going. Now you substitute. Everywhere there's a u, you replace it with x. Everywhere there's a dv, that becomes cos x dx. U is x, v we get from here, so that's sine x. V is still sine x, du is dx. And then we can integrate this one. The integral of minus sine x, sounds like cos to me. And then we'll verify this because again, this looks a little too much like magic. So our function x sine x plus cos x plus c, take the derivative, we use the product rule, derivative of first times second, first, derivative of second, derivative of cos is minus sine, these two will eliminate, our answer is x cos x, well that's what we were trying to integrate, magic. Okay, let's try this one. Now, you might be looking at that and saying, how am I supposed to make that u dv when I've only got one term here? What if you put a 1 in? Will that change anything? Now it's a product. So dv you must be able to integrate. Can you integrate 1? Yes. Can you integrate ln x? No, if you could, you would have done it right away. So that means u must be ln x, because ln x can't be dv, we don't know the integral. So although this is going to get more complicated when we take the integral, the overriding rule is you must be able to integrate dv. So we were not allowed to put ln x in for dv. Our only option then was putting the 1. If you know what u is, you can take the derivative. Derivative of ln x is 1 over x dx. If you know what dv is, you can integrate. What has a derivative of 1? That would be x. Now do your substitution. U is ln x. dv is 1 dx. U is ln x. V is x. V, we said was x. Du, 1 over x dx. We can simplify this. That just becomes 1. And then the integral of 1 we know is x. Now at this point, you might believe that this works. If you would like to, feel free to take the derivative and verify that this is your answer. So every once in a while, we get an occasion where there's just one term in here, and we make it a product by multiplying by 1. Let's do some more fun things. U and dv. This one is the one that will become more simple, and we had 2 choices because we could integrate both. And there's the rule we're using, and so we'll let u equal x squared. dv will be cos x dx. Derivative of x squared, 2x dx. Integral of dv sine x. Double check because the plus minus signs can get confusing. Derivative of sine positive cos. We're good. Keep going. Let's do the substitution. All the u's become x squareds. V is sine x. There's our sine x again, and du is 2x dx. Okay, every time we've done this so far, we've gotten to the integral, we've known the answer. But now we don't. So let's look at it. 2x sine x. That's a product. How do you do products? Oh, we have to do this again. So how did you know that this had to be done using this new method of ours? And the way we knew is that it was a product, something multiplied by something else. So huge, huge, huge hint on this. If you're doing this for a second time, make sure you set up the question exactly as you did before. If u was the variable to an exponent and v was trig, do it again. So u is variable exponent and dv is trig. If you mix them up, you'll end up undoing what you did and you'll end up back where you were. Okay, so u is 2x and dv is sine x. Integral of sine is minus cos. Now, why is that? Derivative of cos is negative sine. So we'd need another negative to get rid of that negative. Let's try that again. Derivative of cos is negative sine. So derivative of negative cos is positive sine. Derivative of 2x is 2dx. Do the substitution. Now be really careful and watch this negative sign. So we keep our x squared sine x. There's that negative sign. And I'm going to put brackets in so I get everything right. So this is uv. U was 2x, v was minus cos x. Minus integral of v du. V was minus cos x, and du was 2 dx. We're going to look at that again. This is what we had in the step above. We keep the integral of x squared cos x dx equals x squared sine x minus. Integral of x squared cos x dx equals x squared sine x minus. Inside here, we're putting uv minus integral of v du. So u times v gives us the minus 2x cos x, and minus the integral of v du gives us the minus 2 dx times cos x. Look at all these negative signs. I would clean those up before I go any further. So 2 negative signs here, and 1, 2, 3 negative signs there. So this one becomes positive, this one stays negative. Now can we integrate this? Oh, good, we can. So because it's not a variable times cos x, we can just say what has a derivative of negative 2 cos x? That'd be negative 2 sine x. And then we're done. So can you predict how many times you're going to need to repeat this substitution cycle? We had x squared cos x. X squared became 2x, 2x became 2. How long did it take us to get rid of the exponent? And the answer is, however big the exponent is, that's how many times you have to repeat this. So if I gave you x to the 5th cos x, you would have to do the substitution 5 times. I know, it's lovely. Okay, let's try another one. E to the x cos x. Can you integrate cos? Yes. Can you integrate e? Yes. Which one gets more simple as you take the derivative? Cos becomes negative sine, e becomes e. It's much of a muchness. So when you come up with your substitution, I tend to let u equal cos. And the reason I do it is it gets confusing figuring out the plus and minus signs. So we're generally better taking derivatives. The truth of the matter is it does not change anything in terms of which one you make u and which one you make dv. Feel free to do it the other way around and see if you get the same answer. So the only reason I'm suggesting this is because I find it slightly simpler to get my plus minus signs right. Derivative of cos minus sine. Integral of e to the x, e to the x. Do your substitution. U was cos x, v was e to the x. So there's our v again. Du minus sine x. Change those two negatives right away, otherwise we'll confuse ourselves. And the integral of e to the x sine x, that's another product. We're going to have to do this again. Now, when you do this again, same warning as last time, whatever you did last time, do it again. If U was trig and V was E, do that again. So U is the trig part, dV is the e to the x. Derivative of sine is cos, integral of e to the x is e to the x. This one should be a little bit easier to follow because we don't have a minus sign. So we'll keep the e to the x cos x, we'll add, and then this integral is getting replaced with uv minus integral of v du. uv minus integral of v du. Wait a minute, that's a product again. Are we just going to cycle this forever? Because it looks like we are. So let's just take a look at this. What's on the left-hand side? Integral v to the x cos x dx. Integral v to the x cos x dx. What if we put those two together? So we have two of those. So if you wanted to know what one of these was equal to, what would you do? You divide by 2. Huh, how cool is that? So when you have e's and trig, they tend to cycle twice, and then you should recognize the same thing on both sides of the equation. Put them together, divide by the number. Now you might be looking at this and saying, okay, why didn't we divide c by 2? What's going on here? The reason you just don't bother. C is some number. If you divide some number by 2, you get some number. So we tend just to put the c at the end. Huh, isn't that astonishing? Maybe we should take one more look at this. Product had a choice. You could integrate either one. I let u equal the trig because then I get my plus and minus signs done properly. We did the substitution. We got a similar thing, not quite the same, but it was a product again. We did the same substitution that we did before. If trig was u, trig is still u. If v was e, v is still e. Did the integral again and ended up with something very much like we started with. Put the like terms together and divide. How do you recognize those again? Combinations of e's and trig. Your job today. Get comfortable with integration by parts. You're doing 1 to 12. They won't all be this hard. They're going to start out a little more simple, so don't panic. You're going to be just fine.